Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of applications of integration. And if I talk about the question which is given to us here from this topic, the question tells us let x belongs to R, that is real numbers, and f of x, it is nothing but x plus mod of x divided by 2, and g of x, that's another function which is given to us as x or x square. X when it is the values of x are less than 0, and x square when the values of x are greater than or equal to 0. Then the question further tells us to find out the area which is bounded by the curve y equals to f of g of x and the lines y equals to 0 and 2y minus x equals 15. So we have to figure out the area between these three regions, and we have been asked to find out what is the area of this between the three regions equal to. So we have to answer the question as well. Let's see how to solve this question further. Before starting off with the solution, I would first like to tell you that please do subscribe to my channel and support the channel as well, because it takes lots of efforts in making these videos for you on everyday basis. Let's see how to solve this question further. So we know here that there are two functions f of x given to us as well as g of x given to us. And we have to figure out the region between the curves where one curve is y equals to f of gx. So if I see y equals f of gx, if I want to figure out, it's nothing but f of g of x. So everywhere you have x here, in the function f of x, you will just put g of x. So we know already from the question that f of x it's given to us as x plus mod x divided by 2. So if I have f of gx to be found out, I can just write that as g of x plus mod of g of x divided by 2. Now, once I have this, I see here when it is g of x, I have been given two functions for different values of x when it is less than 0 also and when it is more than 0 also. So if I have to find f of g of x, so let's figure out that. So I get for x less than 0 and then for x greater than or equal to 0 also. So let's do that. So for x less than 0 first. So when I have for x less than 0, the function f of gx, it's basically g of x plus g of x in the mod divided by 2. So y in this case, which is f of g of x, if I'm putting here, we know for x less than 0, g of x is x. So I'm just putting x plus mod x divided by 2. And when basically x is given to me, it is less than 0, mod of x is basically minus x. So it becomes x minus x divided by 2, and x minus x is 0, 0 divided by 2 is 0. So you get y equals to 0. And the other one we have been given is when x is greater than or equal to 0. So when x is greater than or equal to 0, now in this case, the function f of gx would make it x greater than or equal to 0. Instead of g of x, I can just put x square everywhere. So in this function, if I'm putting x square divided by 2, so x square as it is. Now mod of x square is always positive. Square of anything is always positive. So mod of x square is also going to make it x square divided by 2. Now x square plus x square, you get 2x square divided by 2. 2 cancels, you are just getting x square. So you're getting f of gx is equals to x square, means y is equals to x square here. Now if I see, I have got my function which is asked to us, which is y, which is nothing but when x is less than 0, the function's value is 0. And when x is greater than or equal to 0, the function's value in this case is given to us as x squared. So you have this one function. The other function, it's given to us y equals to 0 line and 2y minus x is equals to 50. So once I have y equals to 0 line, let's try to plot this region first now. So this is x-axis, this is y-axis. One is this line y equals to 0. The other line we have been given is 2y minus x is 15. So 2y is x plus 15. And from here I get y is x over 2 plus 15 over 2. So from here, if I compare this line's equation with y equals to mx plus c, I get from here m, slope is half, and the y-intercept is 15 over 2. So once I have my y-intercept as 15 over 2, if I'm putting that here, let's say somewhere here. So you get this 0, comma 15 over 2. 15 over 2 is basically 7.5. So from here you get this y-intercept, and you have been given slope as half. Half means it's a positive slope. Positive slope means we will have an ascending line. So your line would look something like this. And then further we have also been given that we have to find the region between the three curves. So one is y equals to f of g of x. If I plot that also, let's see what does it become. For x less than 0 means for all the values of x, y is equals to 0. So it is here only. So it's a straight line. And for x greater than or equals to 0, it is y equals to x square. So y equals to x square means it's a parabola. So it is basically a parabola here. So yeah, we'll have this type of parabola. Now we have to find the area of the region between these curves. So I get this entire thing between the line and the parabola as well as this line. This is your entire region. So if I see and draw it here, this is basically your entire region. You have to find the area of this entire region. Let's figure out. Now, if I see this entire region, it is composed of two regions. One is this triangle and the other is the region between the line and the parabola. So if I want to figure out the area of the region 1, so region 1, I can see basically it's a triangle. And if I figure out this points of intersection of this parabolas and the lines, I'll get this coordinates also. So then we can easily find the area of the regions. So first let's figure out this intersection points. For this intersection point, I know y is equal to x square, and the other is equation of a line, which is y equals to x plus 15 over 2. So if I equate both of them, x square becomes equals to x plus 15 over 2. 2 goes there, becomes 2x square minus x minus 15 equals to 0. Now once I have this, it's minus 30. So if I want minus 30, I can write that as minus 6x plus 5x minus 15. So 2x common, x minus 3 plus 5, x minus 3 equals 0. So from here I get x is minus 5 over 2 or x is 3. So x cannot be negative on the right hand side, so x has to be 3. And when x is 3, if I want to find y, it is x square, which is 3 square, which is 9. So you get this coordinates as 3 comma 9. And if I figure out this coordinate, I know already that y is 0 here. So when y is 0, if I put it, it is also lying on the line. So if I put in this equation y as 0, x becomes minus 15. So you have that as minus 15. Now once I have this two coordinates, I have to figure out the area of this triangle. So area of the triangle, if I see, it is half into base into height, where base is of 15 units. And height, if I see, it's 15 over 2 units. So I get the area of the first region, that is area of triangle half base height, which is half 15, 15 over 2. So that gives you 225 over 4. So you get the area of this triangle as 225 over 4 square units. Now, the second region, if I figure out, it's basically the area between this parabola and the line. Now, when I have the area between the parabola and the line, so basically this is your vertical strip that is present. So area between the parabola and the line, that is nothing but area of the second region that we have to figure out. So if I have to now just find the area of the second region, which is between the parabola and the line, it is given by x1 to x2, y dx, where y is in basically terms of f of x. So I see the limits of x1 to x2. It goes from 0 to 3. So your limits of x goes from 0 to 3. Y is in the terms of function of x. So y in terms of function of x, if I see, the upper function of y in terms of x is x plus 15 over 2 minus y in terms of the parabola's equation, it is x squared. So minus x squared dx. So now if I take the integral of this expression, we get this as half common. Integral of x plus 15, integral of x is x squared by 2 plus integral of 15 is 15x minus integral of x square, which is x cubed divided by 3. The whole thing has the limits 0 to 3. Now once I have this with me, I can further evaluate this and solve. So you get half x square over 2 plus 15x, the limit is 3. So that gives me 3 square, that is 9 divided by 2 plus 15 into 3, which is 45, minus this gives you 3 cube divided by 3, which is 9, 27 divided by 3, which is 9 basically. And then I put the lower limit 0 and everything will turn out 0. So basically this entire thing is 0. So if I further try to solve it, this gives you 9 over 4, this gives you 45 over 2, and this gives you 9. So if I try to make the denominator same for all of them, so if I make it same, it's multiplying by 2 here and it's multiplying by 4 here. So this gives you 9 plus 90 minus 36 divided by 4. So 99 minus 36, which is nothing but 93 and 63, 63 divided. So you get the value of this integral as 63 divided by 4. Now, if I see, I have got the area of first region as 225 divided by 4. The next one was 63 divided by 4. So if I just add all of them, the total area of the region that is asked to us, it's nothing but area of first region plus area of second region, which is 225 divided by 4 and adding it with 63 divided by 4. So 285 to 88 divided by 4, which is 4 sevens 28 and 4 twos 8. So 72 square units. That is nothing but the area of the region which is asked to us between the three regions. One is y equals to f of gx, one is y equals to 0, and the other is this line 2y minus x equals to 15. So area of this entire region is 72 square units. I hope you have understood how to solve this type of questions. So first we figured out what is the function of gx, f of gx. Once I got f of gx simplified, I had the other two. One is this line and the other is also this line. And then I plotted this and I got the region between them. Once I got the region between them, I just found the area of the shaded region and that matches with answer of 72 square units. So we get the answer for the question asked as 72 square units. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well and do subscribe to my channel and share these videos with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.